Okay, welcome. So today we're going to talk about average rate of change. Average rate of change is slope of a curved line. I'm going to try to move this desk a little bit because it's not really all that great. That's better. Still here. Okay. um, Average rate of change, it is the slope of a curved line. So now we're talking about things that are not linear anymore. We're talking about, this is a quadratic function, and we'll talk more about what that means next unit. And we're also going to do exponential functions. So x to the third power, right? Or negative x to the third power. We'll talk about that also a little bit more later. So for instance, here's the function f of x equals x squared. So average rate of change is, first of all, I have to give you an interval. I have to give you a starting x point and an ending x point. So for instance, on this one, for example, let's go from, I want to find the average rate of change, and I'm going to always represent this by AROC. It's just easier to say. On the interval, let's go from 0 to 4. Okay, now, that's an x value, and that's also an x value. So basically, remember the slope formula, right? The slope formula was y2 minus y1 over x2 minus x1. But things are going to change now. Remember, because we don't use y anymore, we use f of x. So I'm just going to simply erase the two y values, and this is going to be f of x2 minus f of x1. So I'm still trying to find 2 points on this graph. So I know the x value of 0 already. So I'm going to go and put a little point here, because when x is 0 on this function, the y value, or the f of x value, is also 0. So now I've got a solid point that's on this graph. I'm looking for a number 2 point, right? When x is 4, now you can't see it on this graph, but remember what we talked about when we did x and y intercepts. You have a road map here, or here. The road map here gives you all you need to know. You don't actually need the graph for this. Now, from when we talk about end behavior and stuff, it's really, really nice to have a graph, but technically speaking, you don't need that either. But anyway, I know this x value is also 4. So what I would do here is I would go to where x is 4. Now I can't see it, but because I know the roadmap, I know what the f of x value is when x equals 0. So I'm just going to substitute 4 into there, and I get 16. So my other point is, I'm just going to make it up here and pretend like this is it, would be 4 comma 16. And this was 0 comma 0. Now here's where average rate of change is exactly what we know how to do from before. I am trying to find the slope, and I'm just dashing this line so you can see it differently. I'm trying to find the slope of this line from when the point connects from 0, 0 to 4, 16. So I can just count up and over if I can see it. If not, I'm just going to put it into the formula. So 16 minus 0 over 4 minus 0. This is obviously going to be very easy. It's just 16 over 4, which gives me 4. So the average rate of change on the function f of x equals x squared on the interval 0 to 4 is 4. Okay, so let's try another one together, and I'll make this one so you can see it actually. So again, it's slope of a curved line. That's all it is. We just have to kind of be a little bit genius-like about how to solve it if we don't actually see it on the graph. Okay, let's use the same graph, but let's go on the interval from -2 to 0. Okay, I'm always going to use brackets in there, and I'm always going to give you an x pair. So if I don't give you two x values, you can't find average rate of change. It's not possible, because you're like, well, where do I go? Because obviously, if I was going from this point to this point, that's a certain slope. But if I was going from this point to that point, it's a much, much different slope. They're totally different. That's why we call it an average rate of change, because it's not always going to be the same. Again, let's just backtrack a second. Let's just say I had a line that looked like that. It has nothing to do with the curved line at all that's on the graph. But that line, if it was straight, but it's not really straight, but if it was, pretend it was, the slope would be the same on every single point of that graph. It would be the same exact thing. That's why on a straight line or a linear function, we call it a constant rate of change. This can't be constant on a curved line. It's just an average. All right, anyway. So -2, this is when x is -2. And here we can actually follow. Where is the function when x is -2? Well, it's right there at 4. So this point is -2 comma 4. And then where's the function when x is 0? We just did it. It's at 0. So I have my 2 points. I am trying to find the slope of that straight line, which is something we know how to do. I can simply just count down and over here. So it's 1, 2, 3, 4 over 1, 2. So it's down 4 over 2. And yeah, I know it doesn't look like that, but these go up by 2's. The slope of this line is -2. Okay, so the average rate of change on the function f of x equals x squared on the interval -2 to 0 is -2. Let's go with some answers on the fever form. So, number 1, you should have 3. Number 2, it's 0. Number 3, it's -3, or it should be. Number 4, you can't do it! Ha ha! I tricked you. Can't do it because I didn't give you intervals. If I don't give you the intervals, you can't do it. 5, can't do it. Ah! Okay. And the last one, I got 21, but check that because I don't know if that's right or not. I did it real quick in my head. I need to see work on your fever forms, okay? Some of you are turning in your fever packets on Fridays, which is awesome, but you're not showing me the work, which is not awesome because I'm taking points off. All right, average rate of change. Bye-bye.